Okay, this is the review for the Chapter 11 test. I'm running through the whole thing. Watch what you need, see what you know. So, for 1 through 6, it says determine whether each of the sequences are arithmetic, geometric, or neither. I hope we know that at this point. We'll just run through it. On number 1, each time we are subtracting 6. So if we subtract the same number each time, that means it's arithmetic. Number 2, looks like we're adding 4, then adding 5, then adding 6. So if we're adding different numbers each time, that makes it a neither pattern. The next one, we're going from 2 to negative 1.5. Looks like we added 1.5, then added 1.5, and then 1 plus 1.5 gets me 2.5. So it's a little bit weird, but I am adding 1.5 each time, so that makes it arithmetic. That's one many kids will miss. Number 4, 3 to 6, multiply by 2, 6 to 12, multiply by 2, multiply by 2, multiplying by the same number each time, geometric. Number 5, add 3, add 3, add 3, that makes it arithmetic. Number 6, I am multiplying each time by negative 3. Oh, that looks weird. Multiplying by negative 3 each time. So if I multiply by the same number each time, that makes it geometric. So there is 1 through 6, finding the pattern. On number 7, now we're focused on what's going on. It says express the sum using summation notation. Write it using sigma. So I gave this a little bit easier to you. I wrote it with multiple choice. Let's look at what's going on. It goes 1, 4, 9, 16. So I'm looking for the pattern. Each of those numbers, 1, 4, 9, and 16, are all numbers that are being squared. So I think my formula is a squared. Okay, so it's not a, it's not d. If I plug in 1 here, if I plug 1 into my equation right here, and I get 1, I plug it in, I'll get 1. And then if I plugged in 2, I would get 2 squared, so I'd get 4. If I plugged in 3, I'd get 9. If I plugged in 4, I'd get 16. And on top, it tells me to keep going until I plug in 4. And that is the pattern I started with. So the correct answer is B. Okay? C does not work because it starts with 2 and it goes till 6, and that's too much here. So the correct answer for 7 is B. Number 8, when we look at the problem, we go 3, 6, 9, 12, 15. We're adding 3 each time. So that means my equation is going to have 3k, or 3, in this case, m. So it is not A, it is not D. So it's either C or B. When I plug in 1, or when I plug in that bottom number, I should get the first number. So when I plug in 1, I should get 3. Well, I do. On this problem, when I plug in 4, I would get 12. Well, that's not what I want. I want to get 3 first. And I would keep going until I plug in 5. When I plug 5 into that equation, I'd get 15. That's what I want. So, letter 8 is C. Number 9 is recursive. It says A1 is 4. I'm trying to find A2, A3, A4, and A5. The formula says take 2 times n plus a sub n minus 1. So for this problem, n is the term. So in this case it's 2. A sub n minus 1 means the previous answer. So in this case it's 4. So 2 times 2 is 4, plus 4 is 8. So the second term is 8. Then I do it for a sub 3. Well, if I'm doing a sub 3, now the value is 3 in the third term. Then a sub n minus 1 means the previous answer. So in this case that's the 8. So 2 times 3 is 6, plus 8 is 14. There's that answer. Do it again. My n is 4. 2 times 4 is 8. I got to use my previous answer. Plus 14. So 8 plus 14 gets me 22. My last one here, I am plugging in 5 for n. And a sub n minus 1. So that case, it's 22, the last answer. So 2 times 5 is 10, plus 22 is 32. there are those problems. Make sure you understand how to do it. That is a problem sometimes kids have. Number 10, a sub 1 is 4. I'm finding a sub 2, a sub 3, a sub 4, a sub 5. My formula says I am taking a sub n minus 1 plus 2. Okay, so the first one, a sub n minus 1, well that's my previous answer, which in this case is 4. So 4 plus 2 gets me 6. Then I go to the next formula, and I'm going to keep going down the line. Okay, so my next one, a sub 2, or a sub 3, I'm plugging in my previous answer. So 6 plus 2 is 8. Plug in my previous answer. 8 plus 2 is 10. Plug in my previous answer. 10 plus 2 is 12. So there's my answers there. On number 11, Pascal's triangle. Since it's the third since my exponent is a 3, I don't know why I wrote over top of that, but since my exponent is 3, I look at it tells me to use 1, 3, 3, 1. I'm looking at the third row of Pascal's triangle. Sorry. Okay. Then I'm plugging in since 3. I'm doing 3 third. Then I do 3x squared. Then 3x to the first. No 3x. Then I'm using the negative 2 and coming back the other direction. So that is negative 2 to the third. Negative 2 squared. Negative 2 to the first. No negative 2. Break it up with some plus signs in between. Now I am simplifying. Taking this first one. 3 cubed and x cubed. So 3 cubed is 27 and x cubed is x cubed. The next step, I've got 3 times 9x squared because I'm squaring both things. And negative 2 to the first is negative 2. So in my calculator I am taking 3 times 9 times negative 2. I get negative 54x squared. Next set, I've got 3 times 3x times negative 2 squared would be a positive 4. So I'm taking 3 times 4. So 3 times 3 is 9. 9 times 4 is 36. My last one, I'm taking negative 2 and I'm cubing it. That would be negative 8. So the answer to that one is that whole part right there. This 27x cubed minus 36. Last two on the front side. So 9-3 means 9 NCR 3. If you know how to plug it into your calculator, it's really easy. Make sure you have a calculator that you know how to do it in. On my graphing calculator, I'm going to type in 9 math button. I'm going to find my PRB menu and down to NCR. 9 NCR 3. Hit enter. The answer to this first one is 84. Then I do it with the second problem. So this time I'm doing 7 NCR button 2, choosing a combination 7 NCR 2. That answer is 21. That easy. It's not tough. The next set, it says determine whether the sequence is arithmetic, geometric, or neither, and then find the common difference or common ratio. So what I want to do is figure out what the pattern is. So in order to do that, I need to know the first few terms of each thing. So if I want to know what the first term is, I'm going to plug in 1. So 3 minus 5 times 1. So that's going to be negative 2. And then I would plug in 2. So 3 minus 5 times 2. So that's 3 minus 10. So that's minus 7. And then I would do a sub 3. 3 minus 5 times 3. 3 minus 15 is negative 12. So my pattern goes negative 2, negative 7, negative 12. I'm subtracting 5 each time. So this problem is arithmetic. And the difference is minus 5 because I'm subtracting 5 each time. So it's an arithmetic sequence and I'm subtracting 5. On number 15, same thing. So a sub 1 is equal to 2 times 1 squared. So 2 times 1 is 2. 2 squared is 4. Then I would find a sub 2. So that's 2 times 2 squared. So 4 times 2, or 4 squared, would be 16. And then I do a sub 3. So 2 times 3 squared. 2 times 3 is 6. 6 squared is 36. I could keep going if I'm not sure, but my pattern goes 4, 16, 36. I'm not adding the same thing. I'm not multiplying by the same thing. So this pattern is a neither pattern. There is no pattern to that one.